Okay, so this is Chapter 7, Section 7.1 and 7.2, the warm-up. How would I name this triangle? What do we know about it from its markings?
It's equilateral.
Yeah, equilateral triangle. All right. How would I name this triangle from its markings? Gage?
Right.
Yep, call that right triangle. What would I call this triangle? Somebody besides Gage. What do we know about it? All the angles are what? Different. So, what kind of triangle? Yeah, it's scalene. More directly, it's acute. It's an acute, and it'd be scalene because the angles are different. So, going off the angles, we could call it acute. All the angles. What does it mean to be acute? All angles are what? Less than 90. What can I call this triangle? Obtuse, because it's greater than 135. What else could I call it? Yeah, isosceles. It's got two congruent sides. All right, simplify radicals. I'll do one with you, and then I'll let you guys. Let's look at number 5 here. Radical 45. We want a factor, right? Do I have any perfect squares that go into radical 45? Perfect squares that go into radical 45. What times what equals 45? Square root. Let's think. Well, yeah, 5 and 9. Are either of those a perfect square? You take a number times itself to get it. 9 is a perfect square, so what can I bring it out of the radical as? 3. All right, so this becomes 3 radical 5. 5, yeah, you can't factor it anymore. It's just 1 times 5, so I leave it under the radical. Okay, go ahead and do attempt these other radicals on this page, and go ahead and do the other ones. See if the rules come back to you, then I'll go through them with you. Okay, so you don't have them, do you? Okay, so do that. We'll do them together then. Okay, so simplify that on your own, and then I'll show you how to do it. All right, so on this one, you have to square both the 3 and the 7. What happens when you square a radical or multiply it times itself? What does it do? Becomes that number, right? So this would be 3 squared times radical 7 squared equals 9. 3 squared is 9. Radical 7 times radical 7 is 7. 3 times 7 equals 63. Okay? Okay, radical 3 times radical 5. Go ahead and do that one real quick. All right, if we multiply two radicals times, we just leave them under the radical, and you multiply times what's under the radical. So this is the same thing as square root of 3 times 5, which equals to the square root of 15. Right? Square root of 15. All right, on this one, what's wrong with this? What's wrong with this, the way, the form it's in? Yeah.
Can't have radical on the bottom.
Right, you can't have radical on the bottom, so we have to do what's called rationalize the fraction. When you rationalize, you just multiply the top and the bottom times radical 2, because we know to get rid of the radical, if I multiply radical 2 times itself, it becomes 2, right? So we rationalize. So we take radical 2 on the bottom times radical 2 on the top, and we get 7 radical 2 over 2. Right? And that's our answer. Questions there? Okay? Proportions. Can you solve this proportion? This should be pretty fresh for you. We did this towards the end of last semester. Solving a proportion. What do I need to do to solve this proportion? What do we do? Yeah, we're going to cross multiply. So it's going to be equals to, so 12 times x is equal to 3 times 16. So that's going to be 12x equals 48, x equals 4. Okay, multiply, solve this proportion. To solve this proportion, we would take 3 times x, that equals 2 times 18. So that's going to be 3x equals 36, x equals 12. When we solve this proportion, what do I need to do when I cross multiply? What do I need to remember to do? Okay, so I cross multiply here and here. So does it become 2x plus 5 equals 4? You're shaking your head, Legan. What did I do wrong? Say again? Yeah. You got to take 2 times this quantity. So it becomes 2x plus 10 equals 4. So then we have 2x equals negative 6. And so x equals negative 3. We've got 6 times x minus 4 is equal to 5 times x plus 4. So that's going to be 6x minus 24 equals 5x plus 20. So then we're going to have x equals 44 when I solve. All right, any questions there? Okay, now we should be into your notes, right? You have this in your notes somewhere? Okay, a theorem. That's how we label a right triangle. Right? A theorem is a statement that can be proven. Alright, these aren't matching up, are they? Alright, that's what we talked about in the puzzle. Okay, so in the Pythagorean theorem, it says in a right triangle, the square of the lengths of the hypotenuse is equal to the sum of the squares of the lengths of the legs. If A and B are the lengths of the legs and C is the length of the hypotenuse, then A squared plus B squared equals C squared. That's the Pythagorean theorem. Remember, A and B are the smaller or the shorter two legs. Right, so you always have to have the two shorter legs equaling the longer leg. Pythagorean theorem. Okay, then we have to find the length of the hypotenuse in the right triangle. How would I set this up, Logan Calloway?
8 squared plus 6 squared equals
Right. 8 squared plus 6 squared equals x squared. So that's going to be 64 plus 36 equals x squared. So 100 equals x squared. So x equals 10 would be my answer. Example 2. Identify the unknown side length as leg or hypotenuse. What is it? The leg or the hypotenuse, Jacob?
The leg of the hypotenuse, 4.
No. The x, what is that? Is that the leg or the hypotenuse? Yeah. So that's the hypotenuse. Then find the unknown length side length in the right triangle. Write your answer in simplest form. How's this going to set up? Seth, how would we set this one up? I'm going to use the Pythagorean theorem.
4x plus 6x equals, no, 4 squared plus 6 squared equals x.
Right, yeah. 4 squared plus 6 squared equals x squared, so that's going to be 16 plus 36 equals x squared, so it's 52 equals x squared, right? So x equals square root of 52. Four goes into 52, right? 4 times 13. So that's going to be, what do I bring the 4 out as? What, yeah, so what's this become? What's the answer going to be?
2 radical 13.
2 radical 13. Oh, okay. So that's it said to do it in the simplest radical form. If it says simplest radical form, you can't calculate it as a decimal. How high up on the wall will a 20-foot ladder touch if the foot of the ladder is 5 feet from the wall? Let's draw ourselves a picture so we can see what we're talking about. There's the floor. Here's the wall. 20-foot ladder. There's 20. And it's placed 5 feet from the wall. So my 5 is going to be here. Right? What do we, how are we going to solve for the height of the wall? How high it is up the wall? Set up my equation. Go ahead.
20 squared equals 5 squared plus x squared.
Right. Right. So don't make this mistake of saying 5 squared plus 20 squared, because 20 is the hypotenuse. So like she said, we say 20 squared equals 5 squared plus h squared. So that's going to be 400 equals 25 plus h squared. So h squared equals 375, right? Now, on this one, if they're wanting a distance, you probably wouldn't put your answer in radical form, right? If you were measuring, you'd want something, you know, if it's, say for example, the answer was 5 radical 13. We don't really know how long that is. But if we calculate it as a decimal, it won't give us the inches, but we'll have a better idea. What is the square root of 375? Someone do that on their calculator.
19.36.
Okay, so we'd say h equals 19.36 feet. Any questions? All right. Find the area of a rectangular rug if the width is 12 feet and the diagonal measures 20. Width is 12 feet, the diagonal is 20. Rectangular rug. Set this one up, Brandon. How would I set this up?
16 x, or 16 squared, 12 squared, 20 squared, equals 20 squared.
Where'd you get the 16 from?
Got 16 on my paper.
Oh, find the area. Yeah, you shouldn't have that in your notes. But how would we get 16? How would we get 16? That'd be part of the problem. Set that up. How would we get 16? Eric.
12 squared plus b squared equals 20 squared.
Right. Okay, b or x or whatever, right. So 12 squared plus x squared equals 20 squared. So that's going to be 144 plus x squared equals 400. So x squared equals 256, right? And x equals, square root of 256 is 16. So now we have that 16. Okay, so how are we going to find the area, Taylor? How would we find the area? Area equals what? Okay, base times height. What's my base and height? 12 and 16. 12 times 16. Right, so that's going to be, what, 192? 192 feet squared. should be the area. Find the area of an isosceles triangle with sides 10, 13, and 13. How can we find h, Aaron? All right, yeah, we have to do the Pythagorean theorem, so we do 5 squared plus h squared equals 13 squared. So that's going to be 25 plus h squared equals 169. So h squared equals 144. So h equals what? What does h equal? Square root of 144, Logan? 12. All right. So then area of a triangle equals what, Kaylee? So area of a triangle? Formula?
Isn't it 1/2 times base?
Yeah, 1/2 base times height. So we can do 1/2 of 10 times h. No, the height was 12, so let's plug that in. 1/2 10 times 12. So that's going to be 60. 60 meters squared. Make sure you put your units squared. Meters squared. Questions? Oh, I got it. Okay. All right, now, a set of 3 positive integers such that a, b, and c satisfy the equation a squared b squared equals c squared are called what? They're called, you probably don't know this, they're called Pythagorean triples. So there are certain combinations of numbers that always will satisfy the Pythagorean theorem. One of them is 3, 4, 5. Right? 3 squared plus 4 squared equals 5 squared. 9 plus 3 squared is 9. 4 squared is 16. Right? So we have 3. So we've got 3 squared plus 4 squared equals 5 squared. That's 9 plus 16 equals 25. Right? So that satisfies the Pythagorean theorem. So 3, 4, 5 is a Pythagorean triple. 5, 12, 13 is another common one. These others aren't so common. 7, 24, 25, 8, 15, 17. I would know these two, right? So the advantage of knowing these Pythagorean triples is this. If you have a triangle, and this is 3, and this is 4, I won't require you to show your work. By the way, Kaylee, in here, I always require everybody to show all their work, how they get the answer. That's part of it. And on the homework and all that, you have to show your work. Let me give you a syllabus too. Yeah. So anyway, I don't have to do the Pythagorean theorem. If I have it memorized in my head, 3, 4, 5 is a Pythagorean triple, I can automatically say, okay, this side is 5 because it's a Pythagorean triple. The neat thing about Pythagorean triples is it works for multiples as well. If you multiply 3, 4, 5 times all those times 2, you have 6, 8, 10. That satisfies the Pythagorean theorem, right? 6 squared is 36, 8 squared is 64, 10 squared is 100. 100 equals 100, right? So there's any multiple of 3, 4, 5. These are all multiplied times 3. 9, 12, 15. Right? So if you have those combinations, You don't have to do the Pythagorean theorem. You know it's Pythagorean triple. So if I knew, another example, we'll use the 6, 8, 10. If I had a triangle, this is 6, this is 10. I know this has to be 8 by the Pythagorean theorem, triple. Okay? Everybody get the idea? So I would know this column for sure. Know this column for sure. Know that one. You'll probably use that one a time or two. But these are the ones you'll see the most. Okay? So it's a little shortcut. It makes life a little easier if you just memorize those. Any questions on Pythagorean triples? Okay, I use two methods here. What's one method we could use? Carly, what's one method I could use to find x? All right, Pythagorean triple. Which one is it? What's that? Right, the 5, 12, 13, right? She recognized that as a multiple of 5, 12, 13, right? So we have 10, 24, and like she said, this would have to be 26. Right? Because it's a Pythagorean multiple. 10 squared plus 24 squared equals 26 squared. Okay, what's the other way we could do it? If you don't recognize a Pythagorean triple, what can you always do? Aaron?
10 squared plus 24 squared equals 6.
Yeah, do the Pythagorean theorem. So we'd have 10 squared plus 24 squared equals x squared. So that's going to be 100 plus, what's 24 squared? Somebody do that for me. 24 squared? What is it? Kelly? 576. 576 equals x squared. So x squared equals 676. So x equals what? Square root of 676. 26, yeah. It's going to be 26. All right. Questions? Okay. Seven two. You guys want to take a break or you want to plow on? What do you want to do? Who wants to take a break? Who wants to go on? Okay, the go on wins 2-1. All right. Here we go. Converse of the Pythagorean theorem. If the lengths of three sides of a triangle satisfy the Pythagorean equation, then the triangle is what? What kind of triangle would it be? So now we don't know anything about the angles, but we know the sides. What could I say? If it satisfies the Pythagorean theorem, what can I say about that triangle? Well, we're going to know it's a right triangle. Right? We know it's right. If it satisfies the Pythagorean theorem. Now, so we just have to plug these numbers into the Pythagorean theorem, but you have to be careful. What do you think happens a lot? Like if I were given this sequence of numbers, what do I have to watch out for? What do I have to do? Okay. Tell me what's wrong with this. What's wrong with that? I'm doing the Pythagorean theorem. Why is that wrong? Kaylee? Yeah. You can't just write down the numbers in the order they're given to you. The longest one has to be what it equals, right? So we have to have the 17 after the equals, right? So 15 squared equals 17 squared. So then we've got 64 plus 225 equals, what's 17 squared? So this is a question mark. We don't know if they're equal. If you don't know something's equal, you're testing it. Put a question mark. So 64 plus 225 equals what is well, let's see, what is 17 squared? I need you guys to help me out. Use your calculators. Come on, do something. Do it.
289.
289. Right, so that's going to be 289 equals 289. That's true. So we could say this is a right triangle. Let's test B. We'll test B. So we've got 12 squared plus 35 squared equals 36 squared. All right, so check those out. Get a number for the left side, get a number for the right side. Again, I should put a question mark over my equal sign because I don't know if it's true. Right? We don't know that yet. So left side, calculate the right side, and then tell me if they are equal. Yeah. Well, you can't wait till the notes are done? You finish the notes? Yeah, so with these restrooms being closed here, you guys should use the restroom. Go right and then right down that hallway. There's a restroom in that back hallway. Okay, that's the one I want you to use. What's the left side equal? Gage? Logan? Well, what did the left side equal? Go ahead, Kaylee. 1392? 1396. What's the right side equal? What's 36 squared? Look, Kaylee? 1296. They're not equal. So, this is not a right triangle. Okay, any questions? All right. Theorems. Theorem 7.3. If the square of the length of the longest side of the triangle is less than the sum of the squares of the lengths of the other two triangles, then the triangle is acute. Right? Then the triangle is acute. If the square of the length of the longest side of a triangle is greater than the sum of the squares of the lengths of the other two sides, it's obtuse. Now, let me exaggerate this a little bit to make this, it makes sense if you think about it, right? So, you know, I've got my right? So if I draw something like that, this is the longest side, right? C. If these are long, together are longer than C, then that means that this angle has to be small, right? The longer I make these sides, the closer the angle is together, right? So, you know, this would be small. It's not so obvious. This is A, and this is B. So that would make this a small angle. It's easier to see with the other example. If the longest side, so here we have C, right? And these are my shorter legs, right? So here, A squared plus B squared would be less than C squared. That means, in other words, if C is really long, this is going to be an obtuse angle, right? It's going to be bigger, right? Hi. We had to start our first period because we had to pass out schedules. So he's about half an hour early. We'll be done. We'll be done at second period is over at 11:02. If you have to come get them before that, that's fine. But that's when we'll be going. We're going to go from 9:32 to 11:02. Yeah. This is first period right now. He can sit in here if he wants to. Right, yeah. Okay, so does it make sense? So just think about, on these two rules. That's all right. It's just, just think about it. If A and B are longer, that's going to make that angle across from C small, acute. If C is really long, right, the angle across from it's going to be big. It's going to be obtuse. Let's see an application of this. Classify the triangle with the following lengths as acute, obtuse, or right. Okay? So square root of 8 is going to be less than 4 because we know 3 times 3 is 9, right? So 8 is the shortest side. So we would take square root of 8 squared plus 4 squared. And we have to see how it's related to 6 squared. All right, so square root of 8 squared is going to be what? What's the 8 square root of, what's 8 squared? Square root of 8 squared?
8.
8. Right, it's 8 plus, what's 4 squared? Logan? 16. And then we've got 6 squared is 36. So that's going to be 24 is less than 36. So the sum of the legs A and B, the sum of the legs A and B is less than, their square is less than the square of 36. Which scenario are we in? What do we have? Is that going to be an obtuse angle, or an obtuse triangle, or an acute triangle? Carly? Yeah, it's going to be obtuse because that's telling me this C is longer, right? It's really long. It's longer than these two together. So this would be obtuse. Right? Okay. Let's check out the other situation. Okay, so we have 20 squared plus 21 squared. How's that related to 28 squared? Calculate that. 20 squared plus 21 squared. Kayla, what do you get? 20 squared plus 21 squared. Haven't got it? What'd you get, Shatise?
841.
Okay, 841. 841. What's 28 squared? Shatise?
784.
784. This time, the sum of the legs is greater than the square of the hypotenuse. Which situation would that model? This one with a really long hypotenuse, or this one where the hypotenuse is shorter? Shatise?
The shorter one, acute.
Yeah, so it's shorter, so it would be acute. Okay? I got it? So this one would be acute. Okay, any questions? No questions. Okay, that's it in the notes, right? I think that's the end of our slide show. Yes, that's it. So, let me get this